In this video, we're going to walk through the way the ACT presents triangle problems. So I like to always tell people that triangles are your friend on the ACT because there's so many of them, and once you learn some of the basics, you can go through these problems very quickly. This means that you can make those fall into that category of problems you know how to do. And they have triangle problems all the way from number 5 all the way up to 60, and it's very easy. But first we're going to look at a bunch of different things that they cluster under this triangles category. First of all, the ACT has 30, 60, 90 triangles on there, and we'll go over all these in just a minute. 45, 45, 90, 3, 4, 5, and 5, 12, 13. These are two of the Pythagorean triple triangles. The sum of the angles is 180 degrees. An obtuse triangle means that one angle is greater than 90 degrees. The sum is still 180, but one angle is greater, and we'll look at those in just a minute. Acute means that all of the angles are less than 90 degrees. Equilateral, all angles equal 60 degrees. Isosceles, two angles are the same, and we'll look at what else that tells us when we take a look at that. But first, I want to start with triangle construction. Triangle construction is something that the ACT has as a fundamental part of the test. And what do I mean by triangle construction? If I take a line that's 3 and this one is 5, if I'm looking for the length of this one, first we notice it's not a right triangle. So I cannot use a squared plus b squared equals c squared. Secondly, if all the ACT is wanting you to do is ask you, that they're asking you, what is the range of possible lengths for this side? This is what they're wanting you to do, is recognize that the sum, that the length of one side cannot be greater than the sum of the other two. Now here's what that means. If I were to take this 3 and then take the 5 like this and lay them completely out flat, 8 is as big as it can be. If it's 8 exactly, it's a straight line. So the length of this third side has to be less than 8. It doesn't matter what it is. It could be a 7. It could be a 6. What else could it be? Well, this is where the ACT gets some people, is instead of just looking at stretching our triangle out, what if we tilt it back over? And let's let this 3 side with a 5 here, and the 3 goes up like this. Now they're asking, how long can this side be? Well, again, if we take this 3 and the 5, if we roll this all the way over to here, they're going to leave 2 that's open. Okay? Remember, the sum of two sides has to be greater than the third. So whatever this side is, 3 plus x has to be greater than 5. So that tells me x would have to be greater than 2 in this situation. So I want you to start with the triangle construction. Another easy way to look at your triangle construction is, let's just say we had this one was a 4, and let's say this was going to be a 7. If I looked at that as if it's a hinge, sort of a pivot point, and it allows me to draw this, if I could just swing this one all the way around, the one that's 4, anywhere along this line, it would be able to make a triangle. I can make a triangle from here to here, here to here, over here. I can make a triangle if I go down here, back up to here. If I go to here, I can make a triangle. So anywhere that I move this side, I can make a triangle back. The only thing that happens is if I go straight over here, it has to be less than 11, because 7 and 4 is 11. And it would have to be greater than, if I pulled it down to here, where that was the 4, and making that edge, the other side would have to be greater than 3. Because 4 plus whatever's greater than 3 would be greater than 7. Okay, so I want to get the basics out of the way. This is triangle construction. Now, with a little bit of that under our belt, let's take a look at some of these special triangles that the ACT has used for many years. 30, 60, 90. the 30, 60, 90 triangle, and frequently you're going to see it. They'll give you a triangle where they'll give you the 90, and they will give you an angle that says 30 degrees. You immediately know it's a 30, 60, 90. Okay? That's the way they're wanting you to do it. The relationship in a 30, 60, 90 is that you start with the 30. Across from the 30, we label as x. Now, the hypotenuse across from the 90 is 2 times whatever this x is. And this leg is the square root of 3 times x. Now, one of the things that I use, I look for little things that can help me remember certain things so that I don't get on the test and forget them. When I see the 30-degree angle, that tells me I will have the square root of 3 in the length of the long side. If I see the 45, 45, 90, it has a square root of 2, not the square root of 3. So that's how we can keep the two separate. So if I'm looking at this, for instance, on the ACT, here's a couple of ways they would present this. This is a 30-degree angle, 90, and they might tell you that this side is 10 and ask you what is the length of this side. What they're wanting you to do is notice immediately, if that's a 10, this is a 5. It's half of my hypotenuse. And this side is going to be 5 square roots of 3. So the ACT has it set up so that it's pretty easy to do these most of the time. Now, where they get a little difficult, and I want to walk through this one, is we'll just take a look at this one. That's a simple one. But other times they may give you one like this and tell you this is a 60-degree angle, and they might tell you this is 10 and ask you what is the hypotenuse. Okay, this is not quite as straightforward because remember our relationship. This is x, this is 2 times x, and this is going to be the square root of 3 times x. So what we have to tell ourselves to solve for this first is that since 10 times the square root of 3 times x has to equal 10, we would write it like this. 10 is equal to the square root of 3 times x. Now we're going to divide both sides by the square root of 3. We're solving for x. Remember, when you do this, you're going to have to multiply the 10 over the square root of 3 times the square root of 3 over the square root of 3. This gives me 10 square roots of 3 over 3. So that is equal to x. That's what this would be, 10 square roots of 3 over 3. Now that makes this side 20 square roots of 3 over 3 because it is 2 times as big as this one. So hopefully this gives you a little bit of insight on the 30, 60, 90 triangles. Now what we want to do is take a second and let's look at those 45, 45, 90 triangles. If at any time the video is going a bit fast for you, that's why I did this in video. You can pause it. You can back up. You can watch it until you feel comfortable that you're ready to go ahead. But at this step, we're going to go ahead and take a look at our 45, 45, 90 triangles. We've got those 30, 60, 90s out of the way. A lot of times, how we get a 45, 45, 90 is the ACT cuts a square diagonally. Remember, a square has all 4 angles are 90 degrees. And if we cut a diagonal, that makes this 45, half of 90. And it makes this one 45, and it makes this one 90 because it's a square. Well, in a square, we remember that all sides are equal. So whatever this is, that would be a 3, this could be a 3. The relationship is this would then be 3 square roots of 2. Not square roots of 3. Remember, the 3 goes with the 30. The square root of 3 goes with the 30. The square root of 2 goes with our 45, 45, 90 triangles. So this is the relationship here. And frequently the ACT would write it up so that it's just that simple. They would tell you that you had a square that had an area of 9 and ask you what would be the length of the diagonal. They're expecting you to know side squared equals 9, so the length of the side is equal to 3, and then along the diagonal here would be simply 3 square roots of 2, and we're done. So that makes this one pretty easy. I'm going to do one of these like the hard one on the 30, 60, 90s. So if we take this one, and sometimes the ACT will do it like this, they'll tell you that this diagonal here is 10. And they ask you what is the length of one of the sides. So now we have to say that the 10 is equal to the square root of 2 times x. This is our x. So now we'll divide both sides by the square root of 2. The pattern should be looking familiar, just like what we did on the other one. Now we multiply 10 square roots of 2 over 2 over the square root of 2. Let me get this right here. We multiply 10 over the square root of 2 times the square root of 2 over the square root of 2. This is going to give me 10 square roots of 2 over 2. But 10 over 2 gives me 5, so it makes the answer 5 square roots of 2. So that would be 5 square roots of 2, and this is 5 square roots of 2. So that's how we look at the 45, 45, 90 triangles. Now, next up on our list is going to be the Pythagorean triples. The Pythagorean triples get their name because a squared plus b squared equals c squared is the Pythagorean theorem. Pythagoras invented this, and we've been using it ever since. And so we're going to take a look at what these Pythagorean triples do for us and how the ACT uses them. So if you take the 3, 4, 5, that means if this leg is 3, this leg is 4, that leg is 5, and that has to be a 90-degree angle. All right, so 3, 4, 5. This works because a squared, 3 squared, plus b squared, 4 squared, that's equal to 9 plus 16 is equal to 25, which is equal to c squared, meaning c has to equal 5. Okay, so that's how the 3, 4, 5 works. And most of the time when you're looking at an ACT math problem and you see that one side of the triangle is a 4, or if you see that the diagonal is a 5, you're going to be in pretty good shape to assume you're working with a 3, 4, 5. It's not 100% of the time that it's going to work that way. Let me show you what I mean. The ACT sneaks one of these in every now and then. They will have a 3 and a 5 on the triangle. And a lot of people think it's a 3, 4, 5. No, it's only a 3, 4, 5 if the 5 is the hypotenuse. In this case, what we have is 9 plus 25 is equal to 34, and it makes this side the square root of 34, which is not a 3, 4, 5 triangle. So you have to watch for that. If you see a 3 and a 5 in there, if the 5 is the hypotenuse, it's a 3, 4, 5. If the 5 is not the hypotenuse, it is not a 3, 4, 5. Now we're going to look at the 5, 12, 13. The 5, 12, 13 is following the same pattern because 5 squared plus 12 squared equals 13 squared. 25 plus 144 is 169, and 169 is equal to 13 squared. So this one works the same. Remember the overall equation is a squared plus b squared equals c squared. Now these only work with right triangles. Has to have a 90 degrees. If I've got a triangle, just as a quick review on this, if I have a triangle that's like this, 4 and 7, that has to be solved using law of sines or law of cosines, depending on what information the ACT gives you. You cannot do that with a squared plus b squared equals c squared because it's not a right triangle. All right. So now that we've covered that, let's take a look at the next thing on the list. The next thing on the list is that the sum of the angles in a triangle is 180. You can count on the ACT having a question on this, sometimes two on every test, okay? They may give you something like this, and a line over here. And they might tell you that this line is equal to, we'll say 135, and this is equal to 60, and then ask you what is the measure of this angle. Well, here's what they're wanting you to do. Wanting you to recognize if this is 135, remember this is a straight line, it has 180 degrees. So I have to say, what can I add to 35 to get 180? And it's 45. So this angle is 45, this is 60. I know that the total degrees in my triangle is equal to 180. I add those two together and get 105. So I can subtract 105 and get 75 is what this angle would have been. So when you're looking at these, you want to be able to recognize where you're missing one. The ACT will do this several times. You'll see some of those problems, and you'll see one in a minute, where the ACT might give you a line like this and draw a triangle like this. They'll tell you this angle, maybe this one's 60 degrees, and maybe this one is 80 degrees, and they're telling you a couple of these things, and over here, they might tell you that this angle is 50, and they want to know this angle. Well, once again, we go back to our 180 degrees. 80 and 50 is 130. Subtract that from 180, and it makes this angle 50 degrees. Remember, since this is across the angle, straight across here, these are going to be equal. Makes that 50. These two add together to give me 110, which makes that angle 70 degrees as well. So, just wanted to give you a little bit of overview on these triangles before we get into working some problems. So now we have the couple of definitions we want to look at. Obtuse. And the ACT will do this sometimes. They will give you a problem and they won't give you a measure of the angle. But they'll say an obtuse triangle has this. Well, when they tell you it's obtuse, it's not a right triangle. So it does not have a 90-degree angle. Obtuse means that it's going to be something like this. One of the angles is greater than 90 degrees. Now remember, you can't have two angles greater than 90 degrees because you can't get over the 180 degrees that's in a triangle. But we could have this one's 105 degrees, and that would tell us these two had to add up to 75 degrees. Doesn't matter what they are. They have to add up to 75 because that one is already 105. An acute triangle means all the angles are less than 90 degrees. An acute triangle cannot be a right triangle, or a right triangle can't be an acute triangle. So when we look at this, you want to know when the ACT throws some of these words in the definition, or when they're describing the problem, they're trying to make sure you understand what these definitions mean and the limits that it places on that problem. And you'll see some examples of these as you work through some practice tests. The last two are special triangles. Equilateral is a fairly easy one, and most people tend to remember it. All angles are 60 degrees, and all the sides are the same length. And so this will come up pretty good. The ACT has one problem I've seen several times, worded differently, is they'll tell you that you have an equilateral triangle with another equilateral triangle inscribed in it, which means that it's at the midpoint of the sides. And they'll ask you, what is the ratio of the perimeter of the small one to the large one? The ratio of the perimeter. Well, they give you no dimensions. Pick your own. We make this a 1, this is a 1, this is a 1. So my perimeter of the small one is 3. Now, the big one. Since it's equilateral triangles, if this is a 1, that would be a 1, and that would be a 1, that's a 1, 1, 1. So now, this is going to be 2, 4, 6. So the ratio is 3 to 6, or 1 to 2 in this particular case. So this is one of the ones that the ACT expects you to know your equilateral triangles. I've also got another problem that trips people up, is they'll give them a triangle like this, and tell you in the text it's an equilateral triangle, but give you no dimensions of an angle. The only thing they told you is it's equilateral. And then they'll ask you, what is the measure of this angle? They're expecting you to know. Since it's equilateral, that would be 60. This is 120. That's a way of testing to make sure you know what the definitions are of some of these special triangles. All right. Now we're going to take a look at the last one on the list, isosceles. The isosceles means that two legs are identical. And we usually represent that with a little tick mark there. But it also means something else. If the side lengths are the same, then the angles across from those sides are also equal. So if this was like a 7 and this was a 7, this angle and this angle are equal. And maybe they've told us that these are 50-degree angles, and they ask me, what's this angle? Well, 50-50, this has to be 80. Sometimes they won't give you this one. They would simply do it another way. They would tell you this is isosceles, and they tell you it's isosceles, but this angle is 80 degrees and ask you what is the measure of this one. They're wanting you to recognize if it's isosceles with this side and this side being equal, these two sides have to be the same, so it would be 50 plus 50 for these two angles plus 80 is 180. Okay, so that's kind of a quick review looking over some of the basic triangles that the ACT expects you to know and the terms they expect you to know. So like I said, if you have any problems or you feel like we went a little fast, don't hesitate to pause the video, back it up, take another look and see how it does. So with that, we're going to start looking at some problems. Now the way we're going to do this is I'm going to put the problems up on the screen and I'm going to give you about 30 seconds to work on them just to get started. Sometimes you may not finish. That's okay, but I like to give you a 30-second head start. Now, if we have some that are more difficult, I kind of know which ones those are, and I will probably give you 45 seconds to a minute, depending on how difficult they are. But for most of these, certainly the ones starting out, I want you to have 30 seconds to think about it, and then I'm going to work through the problem on the screen. You'll see it as I work through the screen and make this happen. So with that, let's go ahead and look. I've got about 22 or 23 problems, something like that, that we're going to be working through that's triangle after triangle after triangle. When you finish this video, I hope the next time you see a triangle problem, that's one of those that you can say, I've got this, and you knock that problem out and move on to the next one. Okay, so let's get started working on some of these ACT problems. We're going to start out looking at number 5 by paying attention to the words like I pointed out in the video where you see that it says a right triangle. That means we have a 90-degree angle in here. Has the legs measuring 18 and 24. So we'll say this is our 18 and this is the 24. It says what is the length in meters of its hypotenuse? Remember, a squared plus b squared equals c squared. So we do 18 squared plus 24 squared equals c squared. So when you set this up, you're going to get 18 squared, which is 324, plus 24 squared, which is 576. And when you add those together, you're going to get 900. And that means c squared is equal to 30 because 30 squared is 900, making B the answer to number 5. Number 9 says, in the figure below, angle ADC is equal to 50 degrees. So we always want to take a second and locate that angle first. A comes down to here, D, and back up to C, and that's 50 degrees, and they've got it labeled for us. Then it tells us ACB is 65. That's AC. B back up to here is 65, and then they tell me that the BAC is equal to 90 degrees. What is the measure of BAD? So if we look at what is BAD, that's this whole angle. Well, we know it's got to be bigger than 90 degrees because 90 degrees is part of it. So we're going to use the information that they have given us. Notice that this is 65 and this is a straight line. So that tells me if that's 65, this one right here has got to be 115. 115 plus 65 is 180. Well, if that one's 115 and this one is 50, we have 165, and that means that this angle has to be 15 degrees. Now remember, they wanted the whole angle, so it's 90 plus 15 is 105, making A the answer to number 9. Number 16. A boat leaves a dock and sails directly north for 5 miles. It then turns and sails 12 miles east. How many miles is the boat from the dock? A lot of times this one doesn't look like it's a triangle problem, but watch what happens. Whenever we're talking about these XY coordinates here, north, east, south, and west, you lay it out in your XY grid. And they've told us that it travels north for 5 miles. So we go north for 5. Then it says we sail 12 east. 12 east. 12, 5. Now it's beginning to look like a 5, 12, 13 triangle, and indeed it is for 16. Number 21. In right triangle, XYZ, below, the cosine of Z is 4 over 7. Which of the following expressions is equal to the cosine of X? A lot of times people get mixed up by getting the wrong angles, but we want to make sure we look cosine of Z. Well, they're expecting you to remember that cosine is equal to my adjacent over hypotenuse. It's equal to the adjacent over hypotenuse. So that's what I'm going to do, is I'm going to use the 4 must equal my adjacent, and the 7 is my hypotenuse. So the first thing we do is go ahead and label the hypotenuse over here is a 7, and as measured from angle Z, it tells me this is a 4. So now what we're going to do is our A squared plus B squared equals C squared. So I have 4 squared plus B squared equals 7 squared. This gives me 16 plus B squared equals 49. Subtract the 16, and I end up with B squared equals 33. Therefore, B is equal to the square root of 33. So let's go ahead and plug that in. This is the square root of 33. Now let's look back at the question. And it said, what is the cosine of X? Cosine of X is here. It's going to be the adjacent square root of 33 over the 7, which was my hypotenuse. Now, another thing you could have done, if you like to look ahead on your problems to help speed up some of the math, you can look and say, oh, the cosine of X, well, the hypotenuse is not going to change. It's still going to be 7, and that tells us it can't be any of those 3 answers because they don't have 7 as a denominator. Then we got the square root of 65 and the square root of 33, and now we get square root of 33, making E the answer to 21. Number 4. The legs of a triangle are 3 consecutive odd integers. If the perimeter of the triangle is 33, what is the length in inches of the longest side? So we're picturing this. They don't tell us any of the numbers. They just tell us they're 3 consecutive odd integers. So if I look at my odds, I go 3, 5, 7, 9. I could write this that 5 is equal to my first one, 3, plus 2. The next one going to 7 would be equal to x plus 4, and the next one would have been x plus 6. So we're going to use this to help solve this problem for us. So when we look at this, we would see x is my first number, plus x plus 2 is the second number, plus x plus 4 is the third number. And they told me that totaled 33. So I add up my x's, 1, 2, 3 x's, plus 4 plus 2 is 6 is equal to 33. Now we subtract the 6 from both sides, and we get 3x equals 27, and divide by 3, and we get x equals 9. Now notice x equals 9 is an answer choice, but you always, before you get to making a mistake like this, you want to look back up. What did they ask for? They asked for the longest side. So that means my sides would actually be 9 and 11 and 13. So it makes 13 the longest side, not the 9, making D the answer to number 19. Now we'll look at 21. In the figure below, points K, Q, P, and N are collinear. The statement collinear means they lie on the same line. So they're not trying to mislead you, and one of the dots is actually not on the line. And the distances marked are in meters. The area of KLMN, so we want to find that one. KL down here, MN, is 33. What is the area of the trapezoid? Now here they're expecting you to know that the trapezoid is going to be this one. And continuing up like this. That completes our trapezoid. Remember, a trapezoid has two parallel sides and two sides that are not parallel. So we want to look and see how triangles help us in this one. Notice up here, I have a 3, 4, 5. That makes this a 3, 4, 5 triangle. Now we look at that and we might think, okay, that's pretty cool, but do we need that? Remember, for the area of a trapezoid, it is simply base 1 plus base 2 over 2 times the height. That's the area of a trapezoid. So do we have all the information that we need? Well, we actually see that my height is going to be a 3. My base 1 is this long base, which, even though I have a 4 and a 2 here, I have a 5 over here. Well, that 5 would actually go here as well. So 2 and 5 is 7, and 4 is 11. So I'm going to have an 11 plus the other side was 5, all over 2 times 3. So in this case, I get a 16 over 2, which is 8, times 3 is 24, making C the answer to number 21. Now, I wanted you to see this because if the ACT had said, and they've done this on several occasions, if they had said, what is the perimeter, not the word area, but the perimeter, then we would have needed our 5 here. We would have known that this is 11 down through here, just like it is now, but we would have also needed this one. That's a 3. So we would have had 2 squared plus 3 squared, and that's going to equal 4, and 9 is 13. That would have made this one the square root of 13. So then our perimeter would have been 5 plus 11 plus, and now we have another 5 plus the square root of 13. And that's how we would have gotten the perimeter. I wanted you to see it so you can see how they can go either way on this particular problem. In triangle XYZ, XY is congruent with XZ. And the measure of angle y is 22 degrees. What is the measure of angle x? This is all about drawing our triangle correctly. And so if we look at this, they've told us, and it doesn't matter how we draw it, but we know that if this is an x and this is y and this is z, it's telling me that my xy is equal to xz. When it tells me that, what they're also telling me is that this angle y and this angle z have to be exactly the same. It tells me that y is 22, so it means this is 22. So I go back to my 180 degrees minus 22 is like 180 minus 44, which makes it 136, or A for 43. Number 12. In the figure below, C is the intersection of AD and BE. If it can be determined, what is the measure of BAC? So we want to look and see. They want this one, BAC. This is one of those times they didn't put the question mark or an X there, but that's what they're looking for. So once again, similar to what we pointed out in the video on the triangles, notice this is a 45 and that is a 35. That would be equal to 80 degrees. 45 and 35 would be 80, which would make this one 100. Now, we know that this angle has to be 45 as well because it's across from this one. And then we do a 45 and 35 again and get 80, making this one 100 degrees, or G is the answer for number 12. Number 25, in the figure below, E is a point on the side AB of rectangle ABCD. The measures are given in inches. What is the area of the triangle? We always focus on what is the question. Area of a triangle. The very next thing you do is you write down the formula for it, 1/2 base times height. Now we start looking. Do we have the info we need? The formula calls for the base. If I look at this triangle, DEC, like this, I see that I have my base. It is 8, so I got a 1/2 of 8. My height, well, I don't see it directly, and then I quickly glance over here, and it tells me that side length is 4. So it doesn't matter where this point is. I could have had this point going over like that. It's still 4 from here to here, which is my height. So in this case, we have 1/2 of, and then we'll have 8 times 4. Half of 32, 8 times 4 is 32, is 16, making C the answer to 25. Number 22. First, they've got this drawing, and they tell us quadrilateral, which means it's a 4-sided shape. ABCD is shown below. AB is 5, so they're letting us know this distance here. So we're on the x-axis, we're going from a -1 to a 4, and that is indeed 5. BC, this distance going from here to here, I'm going from a -1 on y to a +2. That makes this one a 3. And then CD, going from here to here, is the square root of 34, and DA is 6. So let's see what question they have for us in number 22. Which of the following is closest to the perimeter of the quadrilateral? So in getting the perimeter to the quadrilateral, we just add these up. And so if you do the square root of 34, you should get 5.8 roughly. So we'd have a 5.8 plus. Now we got 5 and 3 is 8, 8 and 16 is 14. So we add those together and we're going to get a 19.8, and that makes H the answer to 22. '23 builds off the same concept. Now they've asked us what is the length of AC. Here's where our triangles come back in. The length of AC. Notice it's going to be a right triangle because it's in the XY coordinate plane and it's on a grid point. So we know that we're looking at going from a -1 to a +2. That makes this a 3. We're going from a -1 to a 4, which makes this a 5. So here we have a 3 squared plus 5 squared is equal to, and we're going to get 9 plus 25 equals 34. Okay, so the length of AC is going to be the square root of 34, which makes E the answer to 23. Number 38. At a time when the sun's rays are striking the level ground at an angle of 37 degrees, a tree casts a shadow that's 41 feet long, as shown in the figure below. To the nearest foot, how many feet tall is the tree? Okay, so this is going to be, as soon as you see the ACT give you sine, cosine, tangent values, you know you're using SOHCAHTOA. Okay, we'll write that down so we remember what we're looking for. The next thing we notice is you start on a SOHCAHTOA triangle by labeling the sides relative to the angle the ACT gives you. They gave me the 87, so across from it is my opposite. My adjacent would then be this one, and this would be the hypotenuse. Then I ask myself two questions. First question is, what did they give me? They gave me adjacent. What do they want? They want opposite. That tells me I use the tangent function because it's the only one that has opposite and adjacent in it. So I would set this up and say tangent of, and we're going to say 37 is equal to opposite, which is x over 41. Now we can take the tangent of 37, which the ACT tells us is 0.75. 0.75 times 41 equals our x. And so when we do 41 times 0.75, we get 30.75, which is going to be really close to G, 31. '32. A rectangular tabletop is 14 inches wide and 48 inches long, so we want to go ahead and lay this out. That would be a 14, and this would be a 48. And it said, which of the following is closest to the length in inches of the diagonal? The diagonal connects two corners all the way across from each other. And guess what it's done? It's made us a triangle. And this is a 14, so we have another a squared plus b squared equals c squared. So we have 14 squared plus 48 squared equals c squared. And so if we do 14 squared, we get 196. And 48 squared, we get 2034. 2304. Get that right in a minute. When we add these together, we get 2500, and therefore the square root of 2500 would be 50. All right, so hopefully we can see now that the answer to this one is going to be G for 32. Number 42. In the figure below, E is on AD and C is on BD. The dimensions are given in meters. What is the length in meters of CD? This one's a little bit trickier. We're going to be using similar triangles, and you can see this is my X. Now, we always set this up as a ratio and proportion. 1200 is to X, okay? There's my 1200. I'm going to put it on top, and it is to my X, which goes on the bottom. And now our answer is going to be the 2000 goes on the top to match what we did with the 12. So it's 2000 divided by, and now we have 2640 plus X. Remember, this X is now getting counted here as well. So we're going to cross multiply, and we'll have the 1200 times 2640 plus X is equal to 2000X. Okay, so now what we're going to do is go ahead and multiply these out and then divide by the 2000. So we'd do 1200 times 2640 is equal to 3168000. And now we are going to have a plus 1200X equals 2000X. Now the next step is to subtract the 1200X from both sides. And we're going to end up at this long number, 3168000 is equal to 800X, because we subtracted 1200 away. When we divide that by 800, we get 3960. And since we left the problem set up this way, we know that the X we are looking for is actually this number here. And since we solved for X, we don't have to worry about anything else. We know the answer is 3960, making H the answer to 42. In the circle below, O is the center. Chord AB is 12 inches long and is 8 inches from O. What is the area in square inches of the circle? So the first thing you do is get the area of a circle. You remember your area of a circle is equal to pi r squared. So you tell yourself the first thing I need to know what my radius is. Well, they didn't give me that. We have to figure that out. And we're going to do it using triangles. If I draw a line from here to here, I know that this is a right triangle. And if this is a 12, this line has cut it exactly in half if it's at a right angle, which makes this a 6 and this a 6. So now what we have is a 6, 8, 10 triangle. If you look at it this way, 6 squared plus 8 squared is equal to C squared. 6 squared is 36 plus 64 is equal to 100. And when we take the square root of 100, we get 10. Therefore, this is a 6, 8, 10 triangle. Now we plug that in over here. A is equal to pi times 100, or 100 pi, making J the answer to 48. 52. In the figure below, AB is equal to BC, and AC is the diameter of the circle having a length of 4 centimeters. So we'll go ahead and put our 4 here. What is the area of the triangle in square centimeters? They want the area of the triangle. And remember, the area of a triangle is 1/2 base times height. So the base they've already given me is 4. So I need 1/2 of 4 times. Now, how do I get the height? And when you look at this height, it's going to go straight up. It is actually a radius, exactly like from here to here is a radius. That would have been a 2, and that would have been a 2, giving me 4 all the way across, making this a 2. So now it's just half of 4 times 2, which is equal to 4, making the answer G to 52. The ratio of the side lengths of two similar triangles is 3 to 5. Now, when they tell me this, first of all, they tell me they're similar triangles. That means that if I draw them out, whatever they're drawn out to look like, that this one and this one is going to be the bigger one. And they told me they have a ratio of 3 to 5. That would mean if this was a 3, that would be a 5. The smaller triangle has sides that measure 5, 7, and 9. Okay, so instead of it being an actual 3 there, this one is actually a 5. And that would be my 7, and this would be my 9. So now then, I come back over here and clean this up. I'm in a ratio of 3 to 5. So we set it up. 3 is to 5. That's my ratio. As. Now it asks me, what is the perimeter of the larger one? Well, I'm going to use the smaller one to help me out. 9 plus 7 is 16, and 5 is 21. So the perimeter of the smaller triangle is 21. So I'm saying 3 is to 5, my little is to my big, as my perimeter 21 is to x. So I get 3x equals 105. X is equal to 35, making C the answer to 23. Number 38. The angle of elevation from a point on the ground to the top of a building is 37 degrees. The point is 75 feet away from the building. Which of the following is closest in height, the height in feet of the building? So once again, we see that we got the sine, cosine, tangent values. So we know we're using SOHCAHTOA, SOHCAHTOA. And the first thing we're going to do is label the triangle relative to the 37-degree angle. Across from this is opposite, and this is adjacent, and this one is my hypotenuse. The second thing is, what did they give me? They gave me my adjacent. What are they asking for? Opposite. So we're using tangent again. Now in this case, we write it out. Tangent of 37 is equal to x, or opposite, over 75. Now we can look up here and get that the tangent of 37 is 0.754, and then we'll multiply that times the 75 is equal to x. And when we multiply the 0.754 times 75, we get 56.55, which is going to make x approximately 57, making G the answer to 38. Number 25. Right triangle RST has a right angle at vertex S, okay? And so we'll do it like this, and that'll be S. It tells me the length of ST is 6 feet. That's my long one, so I'm going to label that with a 6. And the length of RS is 2.5 feet. Which of the following values is closest to the length of RT, which is the hypotenuse? So again, we're going to have 2.5 squared plus 6 squared equals the length that we're looking for, x squared. So if I do that, I get 6.25 plus 36 is equal to x squared. That gives me 42.25 is equal to x squared. And then we'll take the square root of 42.25. And with that, we get x is equal to 6.5, making D the answer to number 25. A certain triangle has a perimeter of x meters. One side of the triangle is 60 long and another side is 1/3 the length of the perimeter. And the third side is 1/4 the length of the perimeter. What is the perimeter in meters of the triangle? Okay, so let's go ahead and look at this. This triangle has a perimeter of x. And so that tells, and let's say one of the sides is going to be 60, and the other one is going to be 1/3 of x, and the other side, well, let's just say that was the 60, and we'll say this is the 1/4 of x. So now what I'm looking at is a problem that'll take this shape. It'll be a 1/3 of x plus 1/4 of x plus 60 is equal to x. Okay, x is the perimeter. So now when we do this, we're going to have to first get these in a common denominator, or you could multiply through by 12. That gets us a little bit bigger, a big number there, but it would solve some of these problems. But if I take 1/3 of x, let me just go ahead and do that. I think if I multiply this by 12 all the way across, and this by 12, I end up with 12 times 1/3 gives me 4x, plus 12 times 1/4 is 3x. 12 times 60 is 720 equals 12x. All right, so I have 7x minus that gives me 5x, taking it over to here, is equal to 720. And divide by 5, and we get 720 divided by 5 is 144, making x equal to 144, or E is the answer for 45. Number 29, Janelle is loading a truck by using a ramp as shown below. The ramp is 8 feet long, and the end of the ramp that's resting on the truck is 2.5 feet above the ground. Which of the following expressions gives the angle of inclination of the ramp? Okay, this is using a little bit of different type of math, and you'll see the term arc sine and arc cosine. And sometimes we're going to see like an arc sine, and sometimes they'll use the term sine to the minus 1. Sine to the minus 1. Normally, if you had the expression x to the minus 1, you would expect it to be 1 over x. But sine to the minus 1 does not equal 1 over sine. Okay, so just to let you know, they swap between these two terms. This time we're using the arc sine. That's the much better term because it's less confusing. So what it means when we say arc sine or arc cosine, that means the angle whose sine or cosine or tangent is. So when I come back to my triangle, I go to the angle they've referenced, and across from this is opposite. This is my hypotenuse. So I'll look at my SOHCAHTOA function, SOHCAHTOA, and you notice that sine is the one that has opposite and hypotenuse in it. They gave me opposite and they gave me hypotenuse, so that's the two I need to use. When I use that, I'm going to be using the arc sine of, and now it's opposite 2.5 over 8 is equal to what I'm looking for, and that makes the answer B for number 29. Number 30, what is the perimeter in inches of the isosceles right triangle shown below, whose hypotenuse is 8 square roots of 2? If that's 8 square roots of 2, remember that tells us that this one has to be 8 and this is 8. And they've asked us for what is the perimeter, so we add these together and we get 16 plus 8 square roots of 2. And that should be K for number 30. The radius of the base of the right circular cone shown below is 5 inches. So now I got a picture here. And the height of the cone is 7 inches. Solving which of the following equations gives theta, the angle measured by the slant of the height and the cone and a radius. So here's our radius, the 5. They're wanting this angle right here. So once again, they have given us the opposite and they've given us the adjacent. So we're going to be using the tangent function, which means it's got to be one of these two. So tangent, remember on our TOA, it is equal to opposite over adjacent. So if my opposite is 7 and my adjacent is 5, it's going to equal 7 over 5, making G the answer to 32. Now we get to some of the hard triangle problems. This one is going to be a law of sines. So let's take a look and walk through this. It says, in triangle ABC shown below, the angle measures are as marked and the lengths of the sides are given in meters. Which of the following is an expression for the length in meters of AB? So they're not going to calculate a number in this case, but they want this expression. Now, whenever the ACT gives you a note, make sure you always read it. And if they give you a formula, make sure you use it. The law of sine states that for a triangle with sides of lengths A, B, and C, opposite angles of the measure alpha, beta, gamma, respectively, and then they give you this information here. What it's telling you is that the sine, and we could write it this way, the sine of A is to the length of the side across from it, as the sine of B is to the length of the side across from it. So we're going to go ahead and label the triangle. They have asked us, what is the length of AB? That's the one I want. So if I look at that, I am going to need this angle over here. All right, I need this angle. Well, I can tell that that's a 20 and that's a 135. Those equal 155, and if I take that away from 180, I get 25. So it means this is a 25. So I would now have the sine of 25 is to x, as I look at this other one and they gave me the 20 and the 90, and they gave me everything I need here. So this is going to be the sine of 20 is to 90. All right, and all they wanted was an expression, so we're not plugging numbers in, so we just cross multiply, and we'll get 90 sine 25 is equal to sine 20x. Now at this point we're going to solve for x, so we'll divide by the sine of 20 over here, and that should give us 90 sine 25 divided by sine of 20, making B the answer to 53. This is another hard one using our triangles. Which of the following expressions gives the area in square inches of the triangle? Remember, they're asking for the area, so the first thing we do is we think 1/2 base times height. And then we ask ourselves, which one would be the base? Well, the 5 is going to be my base, so I've got off to a good start, 1/2 of 5. Now I need the height, and they don't really give me a way to get that easy unless I notice that I have an angle here, and across from that angle is equal to my opposite. And this is my hypotenuse. And if I'm using the sine function, I would say that the sine of 65 is equal to x, which is my opposite, over 6. So x would have to equal 6 sine 65. Now we plug that back in to our equation we're solving up here and add in the 6 sine 65. Well, we're getting 5 times 6 is 30 times a half gives me 15 sine 65, and that gives me J as the answer. Now, one of the things I like to point out on this particular problem is this is a number 60, so it's intended to be a very hard problem. But sometimes you can recognize things that help you out. If you looked at this for a minute and you were like, I'm not really sure how in the world I can get that, always scan your answers for help. And you notice that as soon as you see sine, cosine, tangent there, you're thinking, oh, I can use trig on this one. And that's what helps you get through with it. So hopefully this helps you on this one. The answer to number 60 is J. Okay, the last one we're going to do is a little bit more complicated, but you'll see what we're doing on this one. It says the sides of an acute triangle. That means all the angles are less than 90 degrees. Measure 14, 18, and 20. So you'd be picturing something like 14, 18, and 20, except not as a right triangle. All right, it says, which of the following equations, when solved for theta, gives the measure of the smallest angle? Now remember, the angle across from the smallest side, if this is my 14, this is my 18, this is my 20, this angle is going to be the smallest angle. Now, they've given us both sets of information. This is the only problem that I have where they give you an equation you do not use. They have given us the law of cosines, and they have given us the law of sines. You are going to use one of these, but not both of them. Now, one of the things that you have to do in order to solve for this is we need to pick out which equation to use. In order to use the sine of A is to A as sine of B is to B, we have to have an angle. And they did not give me any angles on this. So what I do is I go over to the other one. I do have numbers, and I would know that 20 squared, that's my C, across from this angle here. Okay, oh, that's the 20 is across from that one. This is the 14, so it's going to be 14 squared. Sorry about that. Is equal to, it's going to be the angle across from that, the short side, is going to equal 18 squared plus 20 squared minus 2 times 18 times 20 times cosine of the theta that we're looking for. And that would give us the angle and make the answer J on number 58. Hopefully, this has been able to help you work through these triangle problems and see the many different ways the ACT does them, and hopefully you feel a lot better now as you work on other triangle problems in the future.